Okay, hello everyone, in a new video. In this one we are going to solve an exercise related to mechanics and the chapters of kinematics for grade 10 students. So exercise number 2, the position time equation of a vehicle considered as a particle is given by the following relation. So we have the position expressed as function of time, and here notice that everything is expressed in the SI, so the position is expressed in meters, whereas the time is expressed in seconds. Now number 1, specify the nature of motion. And by specify, it means that we need to state with a justification. So given the position time equation, and we have the quadratic term, which is t to the power 2, since the quadratic term appears in this equation, then it is in the form of x is equal to half at square plus v0t plus x0. So the type of motion in this case is given by UVRM, and UVRM is either given by UARM or UDRM, and this depends on the sign of the quadratic term. So let's justify and say, since the given time equation, since the given position time equation verifies the general form which is given by x is equal to half at square plus v0t plus x0, with half a corresponding to minus 2, then in this case a is given by, so now if we multiply 2 by this 2, so we'll get a is equal to minus 4 meter per second square, which is a negative number. Then the type of motion is UDRM, since the acceleration is negative, and D stands for decelerated. Now in number 2, determine the initial position and the initial speed, and this can be done by comparing the given position time equation and the general equation. So we have that x of t, or x for short, is given by minus 2t to the power 2 plus 10t, whereas the general equation is given in the form of half at square plus v0t plus x0. So knowing that the quadratic term corresponds for the acceleration, this is the quadratic term. The linear term corresponds for the speed, whereas the constant corresponds for the initial position or the position. So here they are asking us about the position and the initial speed. So let's say by comparison, we have that. Now comparing the linear terms in both equations, we can say that v0 is equal to 10 meters per second, because the unit of the speed is given by meter per second in the SI, and we have that. Now as for the initial position, it corresponds for the constant. Notice that here the constant doesn't appear in the equation, which means it is plus 0. Therefore in this case x is given by 0. Notice that I didn't include any unit for the 0, because 0 multiplied by anything is 0. However, the SI unit of position is meters. Now in number 3, they are asking us to determine the acceleration of the vehicle. So notice that in part 1 we have determined the acceleration, which is given by a is equal to minus 4 meter per second square. 4 meters per second square. Now as for part 4, write the expression of the speed of the vehicle as function of time. So this can be done by referring to the nature of motion. So notice that here the nature of motion is given by UDRM, which is a special case of UVRM. And in the case of UVRM, the equation, the expression of the speed is given by V is equal to AT plus V0. Then let's justify and say, since the type of motion is UDRM, then the expression of the speed as function of time is given by V is equal to AT plus v0. So why the time must be expressed as function, why the speed must be expressed as function of time? Because the nature of motion is UDRM, so the speed will change because the vehicle undergoes deceleration. But we know that the value of A is given by -4 meters per second square, and the value of v0 is given by 10 meters per second. For this reason, the general expression of the speed as function of time is given by -4t plus 10, in which everything is expressed in the SI. So here now we have two equations. This is the given equation, and the second equation that we have determined as function of time is given by v of t is equal to -4t plus 10, and everything for sure is expressed in the SI. Now as for number 5, calculate the position. So let's split this part into two parts, this number into two parts. We need to calculate the position and the speed of the vehicle given that t is equal to 2 seconds. Now if we need to calculate the position knowing that the time is given, we need to refer either to one of these equations. Since we are interested in the position, we will refer to this since we know the time. Now let's say position at t is equal to 2 seconds. And here let me say they are asking me about the position, which is denoted by x. If they ask me about the distance, then d is given by x minus x0. So d referred as the distance covered and x is the position with respect to time. So now x is equal to -2t square plus 10t. Now replacing the value of t by 2, we have that -2 to the power 2 plus 10 multiplied by 2. Now plugging this on the calculator, then the position is given by, plugging this expression, then the position x is given by plus 12. Since everything previously is expressed in the SI, so the value of x will be in the SI, which is position, which is meter. So when the time instant is given by 2 seconds, the vehicle will be at the position given by 12 meters. Now as for the speed of the vehicle, speed at t is equal to 2 seconds. Now in this case we need to refer this equation that gives us the explicit expression of v as function of time, knowing that time is equal to 2 seconds. So v is equal to -4t plus 10. Now replacing t by 2 and plugging this on the calculator, then the value of v is given by 2. Since everything is expressed in the SI, so the value of v will be expressed in the SI, which is meters per second. So v is equal to 2 meters per second. So that's it for me in this video, guys. Hope it was beneficial for you guys out there watching it, and see you soon in another one.